Hello there, and welcome to Mysteries Beneath Earth, where curiosity takes a slow breath and science wanders gently through questions that feel both strange and strangely familiar. Tonight, we are going to look at something very precious, something that has driven empires to war, men to madness, and explorers to the ends of the known world. We are going to talk about gold. But we are not here to discuss its price, or its beauty, or the jewelry that might be sitting in a box on your dresser right now. We are here to ask a question that turns our entire history upside down. A question that drifts in from the edges of geology and speculative physics. What if the gold we cherish, the metal we lock in heavy vaults and wear as symbols of eternal love, is not a treasure at all? What if, to a civilization far older and far more advanced than our own, gold was simply waste? It is a thought that sounds almost blasphemous. Gold is the standard of wealth. It is the heavy yellow metal that does not rust, does not tarnish, and glows with the light of a captured sun. We instinctively value it. When we hold a gold coin or a nugget, we feel a specific kind of weight. Density that feels significant, almost authoritative in the palm of the hand. But nature is full of heavy things that we do not worship. Lead is heavy. Uranium is heavy. Yet gold holds a trance over the human mind that transcends culture and time. From the pharaohs of Egypt to the Incas of the Andes, from the vaults of Fort Knox to the circuit boards of your smartphone, gold is the ultimate material. But let us step back for a moment. Let us look at this through the eyes of a stranger, someone or something not from here. Imagine an observer arriving on Earth after we are long gone, looking at our landfills. They would see mountains of plastic, vast lakes of toxic sludge, and buried canisters of radioactive isotopes. To us, these are trash. They are the dangerous, useless byproducts of our technology. We bury them deep underground, or pile them in specific locations, hoping they will not disturb us. We put them in places where they are concentrated, removed from the flow of daily life. Now, look at where we find gold. We find it in veins, concentrated lines running through the rock, often deep underground. We find it in pockets, distinct from the surrounding material. To a geologist, these are hydrothermal deposits, formed by hot water circulating through the crust. But to our imaginary observer, could these veins look like something else? Could they look like injection sites? Could they look like the places where a previous tenant of this planet pumped their unwanted byproducts, sealing them away in the rock before they packed up and left? Tonight, we will explore the possibility that Earth was once a manufacturing floor, or perhaps a mining outpost, for a species that operated on a scale we can barely comprehend. We will ask if the heavy, non-reactive, stable nature of gold made it the perfect spent fuel or shielding material for a technology based on physics we have yet to discover. It is a journey that will take us from the collision of neutron stars to the microscopic bacteria that precipitate metal in the darkness of the soil. Before we descend into the minds of this hypothesis, I would like to ask you something simple. Where are you listening from tonight? What does the room around you feel like? Maybe the lights are dimmed, and the only glow comes from the screen. Maybe you can hear the wind outside, or the hum of the city. Wherever you are, this is the moment we share. A moment to let go of the day's weight and pick up a different kind of heaviness, the golden weight of a mystery. And if you enjoy finding calm in questions that reshape the ground beneath your feet, I would be grateful if you gave the video a like or even subscribed, because this little space of science and rest only grows when more people find it. Now, let's settle in. To understand why gold might be waste, we first have to understand why it is so rare and so strange. In the periodic table of elements, gold sits in a neighborhood of heavyweights. It has 79 protons in its nucleus. That is a lot of positive charge packed into a very small space. To keep those protons from flying apart, it needs a massive number of neutrons to glue them together. This makes the atom incredibly heavy and incredibly stable. This stability is what makes gold noble. It refuses to react with oxygen. Iron rusts because it is eager to bond with the air, crumbling into red dust. Copper turns green as it oxidizes. Silver tarnishes black. But gold remains aloof. It does not bond. It does not decay. A gold ring dropped into a swamp by a Roman soldier 2,000 years ago will emerge today looking exactly as it did the day it was lost. It is chemically immortal. For us, this immortality is a virtue. It represents eternity. But in the world of industrial chemistry and nuclear physics, non-reactive stability often signals something else, an end state. In nuclear processes, elements transform. Hydrogen fuses into helium. Uranium decays into lead. Energy flows from the unstable to the stable. When an element reaches a state where it no longer wants to react, no longer wants to change, it is often because it has reached the bottom of the energy valley. It is the ash left over after the fire has burned out. Think of the ash in a fireplace. It is stable. It does not burn anymore. It is heavy, gray, and useless for heating the room. You sweep it up and throw it away. Could gold be the ash of a process that transmutes elements on a planetary scale? If a civilization had the technology to manipulate matter at the atomic level, turning protons and neutrons into energy or other materials, gold might simply be the inert residue that remains when the useful reactions are finished. It is 19.3 times denser than water. A cubic foot of gold weighs over half a ton. If you found a cube of gold the size of a milk crate, you could not lift it. This extreme density is a clue. In the natural formation of the Earth, as we will see, dense things sink. They fall to the center. They do not tend to hang around on the surface unless something put them there, or unless a violent anomaly brought them back up. The standard geological story tells us that gold is brought to the surface by volcanoes and shifting plates. And this is true. We see it happening. But the distribution is odd. It is clumpy. It is found in specific provinces and belts that don't always align with the simple geology of the surrounding area. Miners speak of bonanza lodes, places where the gold is shockingly concentrated. While just a few meters away, the rock is barren. If we view this through the lens of our hypothesis, these bonanza lodes stop looking like natural accidents and start looking like dump sites. Imagine a massive industrial operation billions of years ago. They are harvesting something from the Earth's mantle, perhaps rare isotopes, perhaps magnetic monopoles, perhaps something we don't even have a name for. As they refine this material, they produce tons of heavy, inert yellow metal as a byproduct. They can't just leave it on the surface. It's heavy and perhaps, in its fresh state, dangerously radioactive or hot. So they inject it back into the crust. They pump it into fractures and cavities, sealing it away in quartz prisons. Millions of years pass. The radioactivity, if there was any, fades. The continents drift. The rock erodes. And then, a hairless ape with a stone tool stumbles across a glitter in the riverbed. He picks it up. It is heavy. It is soft. It is beautiful. He thinks he has found a gift from the gods. He puts it around his neck. He begins to worship the waste of a departure he cannot remember. This inversion of value is not just a clever trick of words. It challenges our ego. We like to think that the earth was made for us, that its resources are there for our consumption. We believe that if something is rare and beautiful to our eyes, it must be universally valuable. But value is relative. To a man dying of thirst in the desert, a kilogram of gold is worth less than a liter of water. To a civilization capable of traveling between stars, or manipulating the fabric of space-time, a metal that merely conducts electricity and sits there looking pretty might be nothing more than ballast. In fact, there is a concept in economics and waste management called tailings. Tailings are the materials left over after the process of separating the valuable fraction from the uneconomic fraction of an ore. In modern gold mining, we grind up mountains of rock to get a few grams of gold. The rock is the waste. The gold is the prize. But what if the equation was reversed? What if the ore was the entire planet, and the valuable fraction was something ethereal? Planetary magnetic energy, or a specific biological essence, and the tailings were the heavy metals left behind. We are going to walk through this possibility step by step. We will look at the stars to see where gold is born. We will look at the Earth's core to see where it belongs. We will look at the strange properties of gold that might make it useful for shielding or containment. And we will look at the silence, the great, empty silence that suggests we might be living in an abandoned house, playing with the things the previous owners left in the attic. This is not a conspiracy theory. It is a thought experiment. It is a way of using science to stretch our imagination, to look at a familiar object and see a stranger. It is an exercise in humility. Because if gold really is waste, it means our most precious symbol of power is actually a symbol of what was discarded. It means we are building our economies on the trash of giants. So, take a deep breath. Let the idea settle. The ring on your finger, the coins in the museum, the bars in the bank. Imagine them losing their luster, not fading, but changing meaning. Imagine them as the slag, the ash, the discarded husks of a harvest that happened before we were born. It is a strange thought, but here in the quiet of the night, strange thoughts are allowed to breathe. Let's follow this vein of gold down into the dark and see where it leads. To understand why gold might be out of place on the surface of our world, we first have to understand the violence required to create it. Gold is not like carbon or oxygen. It is not cooked up in the regular furnace of a star like our sun. The sun is a nuclear reactor, yes, but it is a relatively gentle one. It smashes hydrogen into helium, releasing the light and warmth that bathes our faces today. As stars get older and bigger, they can fuse heavier elements: carbon, neon, oxygen, silicon, eventually reaching iron. But iron is the wall. Iron is the cosmic stop sign. Fusing iron consumes energy rather than creating it. Once a star builds an iron core, the fire goes out. The star collapses under its own gravity and then explodes in a supernova. For a long time, scientists believed that all the heavy elements, including gold, were forged in the chaotic fires of these supernovae. It was a poetic idea. The gold in your jewelry was born in the death throes of a giant star. However, recent astrophysics has refined this story, and the new version is even more violent. It turns out that supernovae might not produce enough gold to explain the amounts we see in the universe. The true alchemist seems to be the collision of neutron stars. Imagine two dead stars, each packed with the mass of a sun but compressed into a city-sized sphere. They are so dense that a teaspoon of their matter would weigh 1 billion tons. They spiral around each other, dancing closer and closer, screaming with gravitational waves until they smash together. In that cataclysmic fraction of a second, neutrons are smashed into nuclei so fast that they don't have time to decay. This is called the R process, or rapid neutron capture. It builds massive, heavy atoms in the blink of an eye. Gold, platinum, uranium. These are the children of the most violent crashes in the cosmos. This debris is then scattered across the galaxy, drifting as dust clouds. Eventually, gravity pulls this dust together to form new solar systems. Our solar system formed from such a cloud, salted with the gold of ancient collisions. As the Earth coalesced from this swirling disk of dust and gas about 4.5 billion years ago, it was a molten ball of fire. It was liquid rock and metal. And here is where gravity takes over. In a liquid, heavy things sink. If you drop a gold coin into a swimming pool, it goes to the bottom. If you drop a gold atom into a molten planet, it should do the same. Gold is a siderophile element, which literally means iron-loving. It binds easily with molten iron. Since the Earth's core is largely iron, and since the early Earth was entirely molten, almost all the gold should have been dragged down to the center of the planet. According to our models of planetary formation, the Earth's crust, the thin, rocky skin we live on, should be almost entirely devoid of gold. It should be as rare on the surface as diamonds are in the sky. The calculations suggest that there is enough gold in the Earth's core to cover the entire surface of the planet in a layer roughly 0.5 meter thick. It is down there, 3,000 kilometers beneath our feet, locked away in the crushing pressure of the iron heart of the world. So, why do we find gold up here? Why can we pan for it in streams in California? Why can we dig it out of the hills in South Africa? Why is it not all gone? Geologists call this the precious metal abundance problem. The existence of gold in the crust is an anomaly. The standard scientific explanation for this anomaly is something called the late heavy bombardment. The theory goes that after the Earth had cooled and formed a solid crust, sealing the original gold in the core, the solar system passed through a messy patch. About 3.9 billion years ago, a massive storm of asteroids and comets rained down on the Earth. These asteroids, remnants of the planetary formation process, were carrying fresh supplies of gold and other heavy metals. Because the Earth's crust was solid by then, this new gold didn't sink to the core. It got mixed into the upper layers of the mantle and the crust, waiting for us to find it billions of years later. Essentially, the science says that all the gold we mine today is alien paint splattered onto the surface of the world long after the main construction was finished. This theory fits the data reasonably well, but it leaves room for questions. It relies on randomness. It relies on a specific veneer of meteoric material being spread evenly and then concentrated by geological processes. But what if the bombardment wasn't entirely random? What if the distribution of these metals isn't just the result of blind luck and tectonic shuffling? Let's reconsider the waste hypothesis in light of this gravity problem. We know that a technologically advanced civilization would understand the same physics we do. They would know that the deep gravity well of a planet is a good place to store things you don't want to move. If you are stripping a solar system of its resources, you are processing vast amounts of material. You are sifting through asteroids, comets, and perhaps even planetary crusts. If gold is the byproduct of your industry, you have a lot of it. It is heavy. Moving it around in space requires energy. You don't want to carry megatons of dead weight on your interstellar ships. You need a dumping ground. You need a gravity well. Earth is the biggest rocky planet in the inner solar system. It has a deep gravity well. It is geologically active, which means it has a self-cleaning mechanism where the crust is subducted and melted back into the mantle. If you were a long-term planner, Earth would look like an excellent trash compactor. Imagine huge transport ships, or perhaps automated robotic barges, descending from the asteroid belt, heavy with the golden slag of their refining processes. They approach the young Earth, or perhaps the Earth of a few billion years ago. They don't land gently. They bombard the planet. They drop canisters, or simply massive kinetic loads of this metallic waste, letting gravity do the work of pulling it down to the surface. This would look, to a distant observer, remarkably like a late heavy bombardment. It would add a veneer of heavy metals to the crust. But unlike random asteroids, which should contain a chaotic mix of elements, perhaps the deposits we find are slightly too orderly, or chemically distinct in ways we haven't yet learned to look for. And then there is the matter of the veins. As we touched on before, gold is often found in quartz veins. The geological explanation is that hot fluids deep in the crust dissolve minute amounts of gold and then shoot up through cracks, cooling and depositing the metal. But looking at a vein of gold, pure and metallic, squeezed between layers of white quartz, it creates a visceral impression of injection. Think of hydraulic fracturing, or fracking, where we pump fluids under high pressure into the ground to shatter rock and release gas. Now imagine a civilization doing the opposite, pumping molten waste metal into the fractures of the Earth's crust to seal it away. They use the planet's own geological pressure to lock their garbage in stone. The quartz forms around it, a silicate sarcophagus. The stardust and gravity perspective tells us that gold is cosmic debris. It tells us that it does not naturally belong on the surface of our world. It tells us that its presence here is the result of a secondary event, an addition from above. Whether that addition was a random storm of rocks or a deliberate offloading of cargo is the mystery we are trying to solve. We are living on a planet that has been salted with a metal that defies the planet's own history. It should have sunk. It stayed. Or it was placed. As we move deeper into this inquiry, we have to look at the specific places where this metal hides. We have to look at the scars on the Earth, the deep mines, and the ancient geology that seems to suggest that the placement of gold was not just a surface dusting, but a deep surgical insertion. Why would they do it? Why bring it here? And if they dumped it, does that mean it's dangerous? Or does it mean it was simply useless to them in a way we can't comprehend? To answer that, we have to stop looking at gold as money and start looking at it as a material with properties that make it very, very specific. Conductivity, shielding, atomic density. The clues are not just in where it is, but in what it is. We are drifting deeper now. We are leaving the surface, with its wind and its scattered stardust, and descending into the crust of the Earth. Down here, the rock is hot, the pressure is crushing, and the silence is absolute. It is in this dark, pressurized world that the strange marriage of quartz and gold takes place. If you were to walk into a natural history museum and look at a raw sample of gold, you would almost certainly see it embedded in a milky white stone called quartz. They are inseparable partners in the geology of wealth. Miners have known this for thousands of years. Follow the white quartz, and you might find the yellow metal. But why? The scientific story is one of water and heat. Deep in the earth, water is not like the water in your glass. Superheated by magma, subjected to immense pressure, it becomes a supercritical fluid. It moves through the rock like a ghost, dissolving things that should be insoluble. It leaches tiny particles of gold from the surrounding crust, carrying them upward through fractures and cracks. As this fluid rises, it cools. The pressure drops, and suddenly, the water can no longer hold on to its golden passenger. The gold precipitates out, solidifying instantly into the cracks, often alongside silica, which forms the quartz. It is a neat, natural explanation. But let's look at it through the lens of our thought experiment. Let's look at a gold vein not as a geological accident, but as an artifact of engineering. When you look at a cross-section of a gold vein, it looks remarkably like a circuitry line on a motherboard. It is a conductive path insulated by non-conductive material. Quartz is a dielectric. It does not conduct electricity. In fact, it is an excellent insulator. Gold, on the other hand, is one of the best conductors of electricity in the universe, surpassed only by silver and copper. But unlike silver and copper, gold does not corrode. It maintains its conductivity forever. So, here we have the planet's crust laced with networks of highly conductive, non-corrosive metal wires, wrapped in high-grade electrical insulation. If you were building a machine the size of a planet, or perhaps repairing one, is this not exactly what you would do? Consider the injection hypothesis. If an advanced civilization needed to dispose of vast quantities of gold produced as waste, they wouldn't just dump it on the surface where it could interfere with the biosphere or weather. They would want to put it away safely. But maybe they didn't just hide it. Maybe they used it. In modern industry, we often use waste products for secondary purposes. We use slag from steel mills to build roads. We use fly ash from coal plants to make concrete. Perhaps the others used their metallic waste to stabilize the Earth's crust or to create a planetary grounding system. The Earth is electrically active. Lightning strikes the surface millions of times a day. The core generates a massive magnetic field. Telluric currents, natural electric currents, flow through the crust. By injecting gold into the fracture zones of the planet, were they creating a path of least resistance for these currents? Were they grounding the continents to prevent catastrophic discharges? Or consider the piezoelectric nature of quartz. When you squeeze a quartz crystal, it generates a tiny electric voltage. When you run electricity through it, it vibrates. This is how quartz watches keep time. The Earth's crust is under constant stress, constant squeezing from tectonic plates. The quartz veins are generating voltage deep underground. By lacing these piezoelectric generators with conductive gold, were they building a massive subterranean sensor network? Imagine a system designed to monitor the stress of the tectonic plates in real time, sending data through the gold veins to a central hub deep in the mantle. The gold is not the treasure. The gold is the wiring. The quartz is not the rock. It is the power source. And we, the miners of history, have been tearing out the copper wiring from the walls of an abandoned house to sell for scrap, completely unaware that we are dismantling the alarm system. This idea of injection also solves a problem of texture. Gold nuggets and veins often look like they were melted and poured. They have smooth, rounded shapes or fill crevices perfectly. While geology explains this through chemical precipitation, the visual language is one of liquid metal forced into a mold. There is a place in South Africa called the Witwatersrand Basin. It is the richest gold field the world has ever known. Over 40% of all the gold ever mined by humans has come from this one specific area. The geology there is complex, ancient, and debated. Some argue it is a placer deposit. Ancient riverbeds buried and solidified. Others argue it is hydrothermal. But the scale is staggering. It is a massive anomaly. In our waste scenario, Witwatersrand looks like a primary dump site. It looks like the location where the transport ships landed, century after century, pouring their molten cargo into the sedimentation basins of an ancient sea. The gold settled, mixed with the gravel, and was buried. It wasn't a natural concentration. It was a landfill. The Carbon Leader Reef in the Witwatersrand is a thin layer of carbon-rich rock packed with gold. Carbon and gold. Life and waste. The juxtaposition is haunting. Let's push the speculation one step further. If gold is waste, why seal it in quartz? Why not just bury it in dirt? The answer might be containment. Quartz is hard, durable, and chemically stable. If the gold waste was originally dangerous, perhaps possessing a radioactive signature that has since decayed, or carrying an energetic charge, encasing it in quartz would be the perfect way to neutralize it. It brings to mind the way we handle nuclear waste today. We are currently building a facility in Finland called Onkalo. It is a deep geological repository where spent nuclear fuel will be buried in copper canisters, surrounded by bentonite clay, deep within the bedrock. We are putting it there to sleep for 100,000 years. We are injecting our waste into the crust, hoping the rock will hold it. future geologists, millions of years from now, might find those copper canisters. The copper will have corroded, perhaps leaving veins of green malachite and native copper. Inside, they might find the decay products of uranium and plutonium. They might wonder why these metals are concentrated in such perfect geometric lines. They might create a theory about hydrothermal copper deposition. We are doing exactly what we suspect the others did. The only difference is the material. Our waste is uranium and plutonium. Their waste was gold, and that difference implies a terrified gap in technology. To have gold as a waste product, you must have mastered the very binding energy of the atomic nucleus itself. You must be operating a furnace not of fire, but of protons. And so, the veins of the Earth become a testament to a physics we are only just beginning to dream of. They are the scars of an industrial surgery, healed over by silica and time. When you wear a gold chain, you are wearing a piece of that scar. You are wearing a wire that once might have connected the heartbeat of the planet to a machine that is no longer here. The conductivity remains, waiting for a current that stopped flowing eons ago. To understand how gold could possibly be waste, we have to leave the geology of the Earth and enter the strange, counterintuitive world of the atomic nucleus. We have to talk about alchemy. Not the wizards with bubbling potions and lead bars, but the true alchemy of high-energy physics. The dream of the ancient alchemist was to turn base metals into gold. They failed because they were playing with chemistry, rearranging electrons. To change one element into another, you have to ignore the electrons and go straight for the heart, the nucleus. You have to add or remove protons. This is transmutation, and we, humans, have actually done it. In 1924, a Japanese physicist named Hantaro Nagaoka managed to synthesize gold from mercury by bombarding it with neutrons. In 1941, American scientists did the same. It is possible we can make gold. The problem is, the process is incredibly expensive and produces radioactive, unstable isotopes. It costs far more to make a gram of synthetic gold than to dig a ton of it out of the ground. So, we stopped. But imagine a civilization that has solved the energy problem. A civilization that falls into the Type 2 category on the Kardashev scale. Capable of harnessing the entire energy output of their star. For them, energy is free. Transmutation is not a difficult magic trick. It is an industrial standard. They don't mine materials. They print them. They take raw hydrogen or helium, or whatever matter is at hand, and they fuse it or split it to create whatever element they need. In this kind of economy, what becomes waste? Waste is the element that is left over when the useful reactions are finished. It is the ash at the bottom of the nuclear furnace. Let's look at the nuclear properties of gold. Gold has one stable isotope. Gold 197. This is very specific. Many elements have multiple stable forms. Tin has 10. Iron has 4. But gold stands alone. It is monoisotopic. In the chart of nuclides, the map of all possible atomic combinations, gold 197 sits in a deep valley of stability. Now, consider a fusion reactor designed not just for energy, but for material synthesis. You are fusing lighter elements to make heavier ones, perhaps creating exotic super-heavy elements for starship hulls or zero-point energy drives. As you fuse protons and neutrons, you move up the periodic table. But fusion becomes difficult as you get heavier. What if gold 197 is the clog in the system? What if it is the point where the fusion process naturally stalls or becomes inefficient for their specific technology? In a fusion chain designed to create element 115 or some other exotic matter, gold 197 might be the annoying byproduct that accumulates in the reaction chamber. It is too heavy to fuse easily into the next stage without massive energy input, but it is stable enough that it doesn't decay away. It is the slag of the fusion era. Think of it like burning wood. You burn wood to get heat, energy, and maybe charcoal, useful material. But you also get white ash, waste. You can't burn the ash. It's done. It's chemically exhausted. In a hyper-advanced nuclear cycle, gold 197 is the ash. It is the nuclear dead end. This hypothesis, the isotope filter, suggests that the gold we find on Earth is the dump from a massive isotope separation process. Perhaps the others were harvesting platinum or osmium or iridium, metals that are often found mixed with gold. In the cosmic scale of abundance, gold is actually more common than these platinum group metals. If they were mining the solar system for platinum to build their quantum computers or catalysts, they would have to filter out tons and tons of gold. To them, gold would be a nuisance. It is dense, it takes up space, and it has no magnetic properties to make it useful in their machines. So they filter it out. They separate the precious platinum and iridium, and they take the useless, heavy gold and eject it. This aligns disturbingly well with the concept of depleted uranium in our own society. We mine natural uranium, which is a mix of the useful U-235 for bombs and reactors, and the less useful U-238. We spin it in centrifuges to separate them. We keep the U-235, and we are left with mountains of U-238, depleted uranium. It is heavy, dense, and slightly radioactive. We use it for tank armor and bullets because it is so dense. Maybe gold is depleted element 79. Maybe the gold we have is stripped of some exotic isomer or companion particle that we don't even know exists yet. We are looking at the empty husks of atoms that were shucked for their seeds. There is another angle to the nuclear argument. Gold is an incredible neutron absorber. If you bombard gold with neutrons, it captures them happily, turning into gold 198, which then decays into mercury. Because of this ability to absorb neutrons, gold is often used in nuclear experiments to measure neutron flux. If the others had a technology that produced massive amounts of stray, dangerous neutron radiation, they would need a shield. They would need a material that could soak up neutrons like a sponge to protect their biological bodies or their sensitive electronics. Gold is soft, malleable, can be hammered into thin sheets, and eats neutrons. It is the perfect lining for a fusion drive or a reactor core. Perhaps the gold veins in the Earth are not just dump sites, but discarded shielding. Imagine dismantling a fleet of starships that have reached the end of their service life. You strip out the engines. The gold lining of the reactor cores is highly irradiated, full of trapped particles. You can't recycle it easily. So you bury it. You bury it in a tectonically active planet where the rock will shield the radiation until it cools down. Billions of years later, the radiation is gone. The gold has returned to its stable, innocent state. And we dig it up, hammer it into rings, and slide it onto our fingers, completely unaware that we are wearing the skin of a dead starship. The isotope filter. Hypothesis changes gold from a symbol of wealth into a symbol of entropy. It represents the point where the creative energy of the universe stopped. It is the brake on the wheel of creation. For a civilization that lived by the energy of the stars, gold was the darkness that came after the light. It was the stuff that wouldn't shine, wouldn't burn, wouldn't work. But for us, children of a chemical age, it is perfect. We don't need it to fuse. We just need it to sit there and look eternal. We value it precisely because it is dead. We value it because it has survived the fire that created it and the industry that discarded it. We are the scavengers of the universe, building our kingships on the refuse of gods. And as we continue to probe the atom, perhaps one day we will learn how to burn the ash ourselves, and gold will lose its value once again, becoming just fuel for the next great fire. We have spoken of gold as trash and gold as a wire. But there is another property of this metal that is perhaps the most critical of all when we talk about surviving in the harsh environment of space or managing the fires of nuclear technology. Gold is a shield. If you look at a photograph of an astronaut on a spacewalk, look closely at their helmet. The visor, that shiny, reflective bubble that hides their face, is coated with a microscopically thin layer of gold. We use gold there not because it is expensive, but because it is the best material we know for reflecting infrared radiation. Heat, while still letting visible light pass through. It protects the astronaut's eyes from the unfiltered burning stare of the sun. But gold does more than just reflect light. Because it is so dense, packed with those 79 protons and 118 neutrons, it is a formidable barrier against high-energy radiation. Gamma rays, the deadly assassins of the atomic world, struggle to pass through gold. A sheet of gold is roughly twice as effective at stopping gamma radiation as a sheet of lead of the same thickness. Now, let's scale this up. Let's go back to our hypothetical civilization, the ones who might have left their fingerprints on our crust. If they were a spacefaring species, or if they utilized high-energy propulsion systems, radiation would be their constant companion and their greatest enemy. In the vacuum of space, cosmic rays and solar flares can shred DNA and fry electronics in seconds. To survive long voyages, you need shielding. Lead is heavy and toxic. Concrete is too bulky. But gold is dense, non-reactive, and can be pressed into sheets thinner than a wavelength of light or cast into thick, impenetrable hulls. Imagine that the veins of gold we find deep in the earth are not just dumped waste, but leftovers from a massive manufacturing effort to build shields. Perhaps Earth was a dry dock, a place where the hulls of starships were plated with gold extracted from the mantle. When the ships launched, they took the best of the metal with them. What was left behind, the spillage, the offcuts, the impure surplus, is what we mine today. But there is a darker possibility. The shielding paradox suggests that the gold veins might be functional right now. We assume that the Earth is simply a ball of rock with a hot iron core. But we have drilled only about 12 kilometers into a planet that is over 6,000 kilometers deep. We have barely scratched the skin of an apple. We do not truly know what lies in the deep crust or the mantle. What if the gold veins are not accidental deposits? What if they are a containment grid? Let's imagine that millions of years ago, something dangerous was buried here. Not waste, but a weapon, or a rogue biological agent, or a technology that could not be destroyed, only suppressed. To keep it from leaking its radiation or its signal to the surface, the engineers would need to wrap it in a shield that would last for geologic time. They couldn't use iron. It would rust away in a few thousand years. They couldn't use lead. It is too soft and would shift with the tectonic pressures. So, they used low gold. They injected millions of tons of molten gold into the rock fractures surrounding the burial site, creating a web of radiation-proof armor deep underground. This would explain why gold is often owned in swarms of veins. It isn't a river, it's a cage. And we, with our dynamite and our drills, are picking apart the bars of that cage. Every ounce of gold we bring to the surface is a gap opening in the shield. There is a strange anomaly in the deep mines of the world. Miners often report feeling a unique kind of heat, or encountering odd magnetic fluctuations in ultra-deep gold mines, like the Mponeng mine in South Africa, which goes down nearly 4 kilometers. Science attributes this to the geothermal gradient, the natural heat of the Earth. And that is likely true. But in our thought experiment, could that heat be the leakage from whatever the gold was meant to keep in? If we look at gold as a shield, it also explains our own obsession with it in a new light. We use gold in our most critical technologies. The contacts in your computer, the connectors in satellites, the coating on the James Webb Space Telescope mirrors, all gold. We are instinctively using the waste of the past to protect the future. The James Webb Telescope is a perfect example. Its mirrors are beryllium coated with gold. That gold is there to reflect infrared light from the dawn of time. It is a shield that allows us to see. There is a poetic irony here. We are using the very material that might have been left behind by an ancient departure to look back into the universe to see if anyone is out there. Instinct. And we are merely the carriers, the biological pack mules doing the heavy lifting to return the waste to its natural environment among the stars. The shielding paradox asks us to consider that the value of gold lies not in its shine, but in its shadow, in what it blocks, what it hides, and what it protects. If the Earth is a container, gold is the seal. And every time we melt a bar, we are breaking the seal just a little bit more. What happens when the shield is fully dismantled? That is a question geology cannot answer, but one that lingers in the quiet dark of the mine shafts. If we are willing to entertain the idea that Earth was a mining camp or a dumping ground long before humans built their first cities, we must ask, did anyone see them? Did the early eyes of humanity witness the others at work? The timeline of human history is short, a few 100,000 years for Homo sapiens. The timeline of geology is long, billions of years. It is unlikely that we overlapped with the original creators of the gold veins. But perhaps, just perhaps, our ancestors arrived in the aftermath. Perhaps they met the caretakers, or the scavengers, or the automated systems left behind. When we turn to the oldest stories humanity has ever told, the myths that rise from the cradle of civilization in Mesopotamia, we find a narrative that is uncomfortably specific about gold. The Sumerians, who built the first cities in the Fertile Crescent, wrote down their history on clay tablets. They told stories of the Anunnaki, those who from heaven to earth came. In the standard academic translation, these were gods. They were metaphors for the forces of nature: sky, wind, water. But in the 1970s, a scholar named Zecharia Sitchin proposed a different, highly controversial reading. He argued that the tablets were not myths, but logs. He suggested that the Anunnaki were not gods, but explorers, miners who came to Earth specifically for gold. According to this interpretation of the texts, the gods needed gold not for jewelry, but for survival. Sitchin claimed they needed to suspend gold dust in the atmosphere of their home planet to repair a damaged ozone layer or to retain heat. A concept that sounds remarkably like modern geoengineering theories involving stratospheric aerosol injection. Whether Sitchin was right or wrong is less important for our thought experiment than the persistence of the mining god motif across cultures. Why would a god, a being of infinite power, care about a soft, heavy metal buried in the dirt? Why would the gods of the Incas demand gold? Why were the Egyptian gods described as having flesh of gold? If we strip away the religious overlay, the behavior of these ancient entities is industrial. They dig, they process, they demand labor. The Sumerian epic of Atrahasis tells of lower-tier gods, the Igigi, rebelling because the toil of digging water courses and mining the earth was too great. To solve this labor dispute, the greater gods created humanity, Lulu, to take over the work. In this dark reading of history, we were not created in a garden to be happy. We were created in a mine to be useful. We were engineered as a biological workforce to extract the waste that the visitors had left behind or needed to retrieve. This would explain our peculiar, obsessive lust for gold. It is not just cultural. It is genetic. It is a hard-coded command in our DNA. Find the metal, dig it up, hoard it. We are like biological robots that have forgotten their mission but still execute the programming. We dig up the gold, we refine it, and we stack it in vaults, waiting for a master who never returns to collect it. There is physical evidence that hints at ancient, inexplicable mining. In the 1970s, mining corporations in southern Africa discovered ancient workings, shafts and tunnels that carbon dating and analysis suggested could be tens of thousands of years old, far older than any known civilization in the region capable of such industry. Legends in Zululand speak of the first people who mined gold for the Starmen. And look at the sheer scale of ancient treasury. When Alexander the Great conquered Persia, he reportedly captured thousands of tons of gold. The Incas had gardens where every plant, every cornstalk, every llama was crafted from solid gold. Where did they get it all with primitive tools? Or were they simply collecting what was already accessible, the surface tailings of a much older, much larger industrial operation? The tales of the first miners forces us to confront the possibility that our economy is a cargo cult. In World War II, islanders in the Pacific built wooden planes to attract the American cargo ships they had seen bringing supplies. They mimicked the form, hoping for the substance. We build banks, We wear chains. We trade futures. We mimic the valuation of gold, perhaps mimicking the behavior of the ancient gods we saw handling it. But we don't know why they valued it. We think it's money. They might have thought of it as coolant, or fuel, or shielding. In South America, near Lake Titicaca, there are ruins like Pumapunku with stone cutting so precise it baffles modern engineers. And nearby, vast ancient gold workings. The legends there speak of Viracocha, the creator god, who came to restore the world after a flood. He is often depicted with a staff that looks like a tool. Was he a savior, or a site manager checking on the extraction progress after a catastrophe? The mythology of gold is never about happiness. It is always about power, curse, and heavy labor. The Midas touch is a nightmare, not a dream. The ring of the Nibelung brings ruin. Perhaps these stories are ancestral warnings. This metal does not belong to us. It belongs to the ones who left. Do not touch their garbage, or their fuel, or their shields, for it carries a weight we are not meant to bear. But we did touch it. We built our world on it. Now, as we scan the skies with gold-coated mirrors, we are essentially holding up a shiny object, signaling to the universe, we found it. We dug it up. Are you coming back for it? Maybe the silence of the universe is a good thing. Maybe we don't want the original owners to notice that the workers have taken over the mine. So far, we have looked at gold in its familiar form. The metallic, yellow, heavy substance. But what if the gold we know is actually the dead state of the element? What if the others used gold in a form so exotic that modern science is only just beginning to rediscover it? This brings us to the fringe of chemistry and physics, to a concept known as monoatomic gold, or high-spin state gold. In standard chemistry, gold atoms like to bond with each other. They form a lattice structure, a metal. This is why gold is solid and conductive. But under certain conditions, gold atoms can be separated from each other. They stop bonding. They become single, isolated atoms, monoatomic. When this happens, the substance stops looking like gold. It turns into a fine white powder. It loses its metallic nature. It becomes a superconductor at room temperature. It exhibits strange properties, including the ability to levitate in magnetic fields and, according to some controversial experiments, even fluctuate in mass. If you are a civilization capable of manipulating matter at the quantum level, you wouldn't lug around heavy bars of yellow metal. You would process gold into this white powder. It would be a room-temperature superconductor, the holy grail of energy transmission. It would be a material capable of defying gravity. The waste hypothesis suddenly takes on a new dimension. Perhaps the yellow metal we find in the ground is the gold that failed to convert. It is the precipitate that fell out of the solution when the process went wrong, or the residue left behind when the monoatomic state collapsed back into the metallic state. The others weren't mining yellow gold. They were manufacturing white gold. The yellow stuff was the slag. This connects eerily with historical mysteries. In the Bible, when Moses comes down from the mountain and finds the Israelites worshiping the golden calf, he doesn't just smash it. He burns it with fire, grinds it to powder, strews it upon the water, and makes the Israelites drink it. Wait, you can't burn gold. If you melt it, it's still gold. To burn gold into a powder requires a chemical understanding that a Bronze Age nomad shouldn't have. Unless he was making something else. Unless the manna from heaven, described as a white, coriander-like substance, was related to this white powder. The ancient Egyptians spoke of mfkzt, a substance offered to the pharaohs depicted as cone-shaped cakes. It was called the bread of light. Sir William Petrie, the famous archaeologist, found tons of mysterious white powder buried in a temple at Sarabit el-Qadim in the Sinai Peninsula, an ancient turquoise and copper mine. The powder wasn't limestone. It wasn't ash. It baffled analysis at the time. Was this the orchil, the high-spin gold? If the advanced civilization used this white powder as a food source for longevity, as some fringe theories suggest regarding telomere repair, or as a fuel for their technology, then the yellow gold we treasure is literally the husk. It is the shell of the walnut after the meat has been eaten. Science is catching up to this ghost. Today, we work with gold nanoparticles. When gold is cut down to the nanoscale, it changes color. It becomes ruby red or purple. It becomes highly reactive in biological systems, used in cancer treatments and DNA targeting. We are realizing that gold has a secret life when it is small enough. The monoatomic ghost hypothesis suggests that the gold veins in the Earth might be chemically unstable. Perhaps they were originally injected as monoatomic fluid, a superconductive nervous system for the planet. But over eons, the field collapsed. The atoms clumped together. The white powder turned into yellow metal. The superconductivity was lost, replaced by simple conductivity. This would mean that the Earth is a ruined machine. The wiring has shorted out. The waste we mine is the debris of a failed planetary computer or a crashed energy grid. And consider the white powder enthusiasts of today. There is a subculture of people trying to make ormus, orbitally rearranged monoatomic elements, in their garages, believing it brings health or psychic powers. Science dismisses most of this as pseudoscience, but the intuition is fascinating. It is the intuition that gold is hiding something, that inside the heavy, dead metal is a light, living spirit waiting to be released. If the others left Earth, maybe they didn't leave because they ran out of gold. Maybe they left because the phase change happened. The environment changed, and their monoatomic technology became unstable. The white powder started turning into yellow metal, becoming heavy and useless. Their technology literally rusted into gold. So they abandoned the site. They left the heavy, yellow, useless residue in the rocks and moved on to a star system where the physics or the local energy fields allowed their white gold to remain stable. We are the crabs living in the rusted engine block of a sunken ship. We think the engine block is a natural formation. We admire the shiny parts that haven't corroded. But we have no idea that the thing we are sitting on was once capable of breaking the speed of light. We just like the way it glitters. And maybe, just maybe, if we learn enough physics, we will figure out how to turn the yellow key back into the white door. But until then, we are just collecting the dust of a ghost. We have spent some time looking at the gold itself, the veins, the dust, the atomic structure. But if Earth was indeed a quarry for an industrial civilization operating on a planetary scale, We should expect to see more than just the leftovers. We should see the holes. We should see the scars of extraction. When humans mine, we change the shape of the world. We tear down mountains. We dig pits so deep they generate their own weather systems. The Bingham Canyon Mine in Utah is visible from low Earth orbit, a man-made wound in the crust over 1 kilometer deep and 4 kilometers wide. But that is the work of a civilization that has been industrial for only a few centuries. Now, stretch that timeline. Imagine a mining operation that lasted for 10,000 years, or 1,000,000. What would those scars look like after the ice ages have scrubbed the land, after the rains have filled the pits, and after the tectonic plates have buckled and folded the surface? They wouldn't look like mines anymore. They would look like geography. Consider the great basins of the world. Geologists generally classify circular depressions as either volcanic calderas, tectonic subsidence zones, or impact craters from asteroids. And the evidence for these is usually strong. We find shocked quartz to prove an asteroid impact. We find igneous rock to prove a volcano. But there are anomalies. There are structures on the Earth that defy easy categorization. Vast, scooped-out landscapes where the mineral profile seems strangely depleted, or where the distribution of heavy metals stops abruptly at the edge of a jagged cliff. In our thought experiment, we must ask, are we mistaking ancient quarries for natural wonders? Let's look at the concept of strip mining on a galactic scale. If the others were harvesting gold or other heavy metals from the surface, they might have used techniques that stripped entire layers of the crust. The resulting depression would eventually fill with water. It would become a lake, or, if it were large enough, a sea. Some alternative theorists point to places like the Richat structure in Mauritania, the Eye of the Sahara. While mainstream geology identifies it as a deeply eroded geologic dome, its perfect concentric circles and flat plateau-like surroundings evoke the image of a massive, rotary excavation tool. Is it a natural uplift worn down by wind? Almost certainly. But the visual resonance with an open-pit mine is haunting. It forces us to wonder if nature and industry might leave similar fingerprints when viewed through the foggy lens of millions of years. Then there are the missing layers. In geology, there is a phenomenon known as the Great Unconformity. In many places around the world, like the Grand Canyon, there is a gap in the rock record. You have rocks that are 500 million years old, sitting directly on top of rocks that are 1.2 billion years old. Where did the 700 million years of rock go? The scientific consensus is that it was eroded away, scoured by glaciers or wind during a time when the continents were high and dry. This is a sound, evidence-based theory. But in the twilight logic of our hypothesis, the Great Unconformity looks suspiciously like a scrape. It looks like someone came along and removed 1 billion years' worth of surface material, perhaps the very layer that contained the heaviest deposits of the early Earth, and took it away. What we are left with is the basement rock, the barren floor of the workshop after the carpet has been rolled up and stolen. We also find strange evidence of ancient activity in the tools we dig up. No, not laser cutters or spaceships, but the evidence of human mining that pushes the timeline back uncomfortably far. In Eswatini, formerly Swaziland, there is a place called the Ngwenya Mine. It is the oldest known mine in the world. Radiocarbon dating proves that humans were extracting hematite and ochre there at least 43,000 years ago. 43,000 years. This is deep in the Stone Age. These were the people who barely had permanent settlements, yet they were engaging in organized subterranean mining. While they were mining for pigment, not gold, it proves that the urge to dig, the knowledge of how to follow a vein into the dark, is almost as old as the modern human mind itself. Did we invent this? Or did we inherit the behavior? Some legends in southern Africa speak of the Chitauri, beings who forced the first humans to dig for gold. These are oral traditions, not history, but they carry the trauma of forced labor. If the others used biological workers, us or our distant cousins, to clean out the difficult, narrow veins that their machines couldn't reach, the memory of that servitude might be encoded in our myths. And what of the ocean floor? We assume the deep sea is pristine, untouched. But the ocean floor is young, constantly recycled by subduction. If there were massive strip mines on the Pacific floor 300 million years ago, they are gone now, melted back into the mantle. The recycling mechanism of the Earth is the perfect accomplice for a crime of theft. It destroys the evidence. However, there are still manganese nodules, potato-sized lumps of heavy metal, sitting on the abyssal plains today. We are currently planning to harvest them. Were they harvested before? Are the fields of nodules we find today simply the ones that grew back since the last harvest? The scars of extraction are difficult to prove because Earth heals. Vegetation grows over the pit. Water fills the hole. Lava covers the wound. But if you look at a satellite map of Earth and you blur your eyes, you don't just see a natural planet. You see a worked surface. You see a world that has been scratched, scraped, and reorganized. We live in the ruins of a quarry. We build our cities in the flat spots they leveled. We sail our ships on the lakes they flooded, and we tell ourselves that the landscape is natural, because the alternative, that we are living on a construction site that was abandoned half-finished, is too alien to accept. If the others were truly advanced, if they had mastered the atom and the star, then perhaps their mining wasn't done with shovels or giant machines. Perhaps it was done with life. In the late 20th and early 21st centuries, scientists made a startling discovery about gold. For a long time, we thought gold nuggets in the soil were purely physical. Tiny grains clumping together due to heat or pressure. But then, microbiologists found something living on the gold. They found bacteria. Specifically, species like Cupriavitis metalliderans and Delphtia acidivorans. These are not ordinary microbes. They thrive in toxic, heavy metal-rich environments. When Cupriavitis metallidurans ingests dissolved gold, which is highly toxic to most life, it doesn't die. Instead, it has a special set of enzymes that detoxify the gold, turning it from a soluble ion back into a solid metal. It literally excretes gold nuggets. The scientific implication is profound. A significant portion of the world's secondary gold deposits, the placer gold found in streams and soils, may be biological in origin. It is grown, not just eroded. Now, apply the filter of our hypothesis. If you wanted to extract gold from a planet without building massive, ugly industrial pits, how would you do it? You would use bioengineering. You would design a self-replicating microscopic machine, a bacterium, that seeks out gold atoms in the soil and water, eats them, and concentrates them into pure, solid pellets. You would seed the planet with these bacteria. You would drop canisters of them into the rivers and the groundwater. Then you would wait. You would let the gray goo of the biological miners do the work for you. They would spread across the globe, processing the low-grade ore, turning the trace amounts of gold in the dirt into concentrated nuggets. Millions of years later, you would come back and harvest the nuggets. Or perhaps you wouldn't need to harvest them all. Perhaps the gold veins we find today are the colonies that grew out of control, the algal blooms of gold-pooping bacteria that were left behind to run wild in the dark cracks of the crust. This idea of biological mining is not science fiction. We are currently researching it today. We use bacteria to leach copper and gold from low-grade waste rock. It is cleaner and more efficient than using cyanide or mercury. If we are figuring this out now, a Type II civilization would have perfected it eons ago. It raises a disturbing question about the biosphere. Is it possible that some of the microorganisms on Earth are not natural evolutions but leftover industrial tools? Are Cupriavidus and Delphtia the feral descendants of alien nanotechnology? Dust to dust takes on a new meaning. The Bible says we are made of dust, and to dust we shall return. But in the context of monoatomic gold and nanobacteria, dust is the bridge between the inert and the living. There is a strange phenomenon reported in ancient alchemy called the projection powder, a red dust that could transmute base metals. In modern science, red gold is gold at the nanoscale. When gold particles are just a few nanometers wide, they appear red. If the others used a nanotech fog, a swarm of gold nanobots, to interface with the planet, to control the climate, or to facilitate their mining, that fog might eventually settle. The nanobots would deactivate. They would clump together. The red dust would turn into yellow metal. The gold dust, found in riverbeds, might be the graveyards of these billions of tiny machines. When we pan for gold, we are scooping up the dead workers of a forgotten age. This biological link also explains why gold is often found in association with carbonaceous matter, the black, oily, organic residues found in places like the Witwatersrand Rand. The carbon leader reef is essentially ohame, fossilized mat of microbes that was incredibly rich in gold. Geologists interpret this as ancient algae trapping gold particles from the water. We interpret it as the biomining colony itself. The bacteria did their job. They concentrated the metal, but the masters never came to collect it. So the bacteria died, were buried, and turned into stone, trapping their golden harvest inside their fossilized bodies. We are entering a realm where the line between biology and technology blurs. If gold is a product of engineered life, then the Earth's crust is not just a rock, it is a petri dish. And the gold we wear is the result of a planetary scale fermentation process that we are only just beginning to understand. It makes the metal feel less like a mineral and more like a relic, a biological artifact. When you touch gold, you are touching the result of a process that defies the simple, brutal logic of gravity and heat. You are touching the result of selection. Someone, or something, designed a way to pull this specific atom out of the chaos of the dirt and hold it in the light. We have looked at the possibility of gold as a shield, as a wire, and as a biological harvest. But let us return to the darkest and perhaps most plausible theory: gold as nuclear waste. To see this clearly, we must look at how we, the humans of the atomic age, handle our own poisons. In the desert of New Mexico, there is a facility called the Waste Isolation Pilot Plant, WIPP. It is dug deep into a massive, ancient salt formation. Here, the United States military buries the transuranic waste from its nuclear weapons program. Tools, rags, debris contaminated with plutonium and americium. They lower it down in drums, stack them in rooms carved out of the salt, and then seal the rooms. The idea is that the salt will slowly flow, plastic and healing, to crush and encapsulate the waste, sealing it from the biosphere for millions of years. In Finland, at Onkalo, they are burying high-level spent fuel rods in granite bedrock. They drill deep tunnels, place the fuel in cast-iron inserts, wrap those in copper canisters, and surround them with bentonite clay. They are building a tomb meant to last 100,000 years. Now, look at a hydrothermal gold deposit. You have a fracture in the bedrock, the tunnel. You have the gold, the waste. You have it surrounded by quartz, the canister or seal, and often you have it associated with clay minerals, the buffer. The geometry is identical. The waste of giants hypothesis suggests that we are looking at the Onkalos of 1 billion years ago. If a civilization was powering itself with a form of energy that produced gold 197 as a hazardous or useless byproduct, they would need to get rid of it. They couldn't just leave it on the surface. They needed deep geological repositories. They would drill or use natural fault lines. They would inject the gold, perhaps in a molten state, or perhaps suspended in a silica-rich fluid, a slurry, deep into the crust. The fluid would cool. The silica would crystallize into quartz, sealing the gold inside a glass-like coffin. This explains why gold is so often native, pure metal, rather than bound up in oxides or silicates like most other metals. Iron is found as rust, iron oxide. Aluminium is found in bauxite. But gold is found as gold. In nature, finding pure metal is rare. It suggests that the gold was refined before it was put in the ground. Nature tends to mix things up. Entropy mixes elements. To find a vein of 99% pure gold encased in pure quartz suggests a reversal of entropy. It suggests a process that separated the gold from everything else and then placed it there. It looks like storage. And consider the markers. When we build nuclear repositories, we agonize over how to warn the future. How do we tell a civilization 10,000 years from now, do not dig here, this is dangerous? We propose giant spikes, menacing sculptures, or pictograms of screaming faces. But maybe the best warning is depth. Maybe the best warning is the rock itself. The others buried their gold deep. They put it in hard rock. They made it difficult to access. Perhaps they assumed that any civilization advanced enough to drill down 2 kilometers would be advanced enough to check the material for danger before pulling it up. But we weren't. We were primitive, greedy, and lucky. By the time we found the gold, any radiation it might have had was gone. The half-life of the danger had passed. We broke into the tomb, found the shiny canisters, and assumed they were gifts. This parallels the cargo cult idea again. Imagine a primitive tribe finding a crashed bomber from World War II. They find the bombs. The explosive triggers have decayed and are useless. The casing is shiny steel. They cut up the bombs to make knives and jewelry. They worship the sky eggs. They have no idea that these objects were originally designed to destroy cities. We are wearing the waste of giants. We are melting down the containment vessels of an ancient power plant to make wedding rings. There is a sobering thought here. If gold is waste, what does that say about the quantity of energy they produced? We have mined roughly 200,000 tons of gold in all of human history. That is a cube about 22 meters on each side. It's surprisingly small. If this is the total waste output of a planetary civilization, they were incredibly efficient. Or we have found only a tiny fraction of what is hidden. Perhaps the mother lode, the central dump site, the Yucca Mountain of the ancient world, is still down there, miles beneath the mantle, waiting. And what if it's not all inert? What if we dig too deep one day? What if we find a vein where the decay hasn't finished? There are stories in mining folklore of bad air, of curse-laden tombs, of miners who waste away after opening a new drift. We call it radon gas or arsenic poisoning, and that is scientifically correct. But in the shadow of our hypothesis, maybe those are the warning shots. Maybe those are the leaks in the canister. The waste of giants theory turns the map of the world's gold mines into a map of ancient landfills. South Africa, California, Australia, the Klondike. These weren't bonanzas. They were the trash heaps, and we are the seagulls picking through the glitter, fighting over the scraps that the giants left behind. If we accept, even for a moment, the unsettling idea that gold is the waste product of a superior technology, we are immediately faced with a new question. A question that is arguably more important than what did they leave behind? The question is, what did they take? In any extraction process, you throw away the dross to keep the prize. If gold, dense, conductive, immortal gold, was the dross, then the prize must have been something of unimaginable value. It must have been a material capable of driving a civilization that spanned stars. It must have been the fuel, the catalyst, the missing element that explains the silence of the Earth's crust. To find it, we have to look at what is missing. We have to look at the gaps in the periodic table and the strange scarcities that geologists struggle to explain. Let's turn our eyes to the platinum group metals: ruthenium, rhodium, palladium, osmium, iridium, and platinum itself. In our modern world, these are the aristocrats of the elements. They are rarer than gold, harder to extract, and remarkably useful. We use them not for vanity, but for work. They are the supreme catalysts. They facilitate chemical reactions without being consumed by them. We use platinum in hydrogen fuel cells to strip electrons from protons. we use palladium in cold fusion experiments, controversial as they are, and in catalytic converters to clean exhaust. In a Type II civilization, one that masters fusion and perhaps even antimatter, catalysts would be more valuable than fuel. Fuel, like hydrogen, is everywhere. The universe is made of it. But the materials needed to control that fuel, to build the containment fields, the quantum bridges, the energy exchangers, those are rare. In our waste hypothesis, it is very possible that the others came here not for the gold, but for the platinum group metals mixed in with it. In nature, gold and platinum often occur together in the same ore bodies. They are chemical cousins. Imagine a refinery the size of a continent. It processes gigatons of ore. It strips out every atom of osmium and iridium, perhaps to build the nozzles of their thrusters, or the heat shields of their sun divers. It strips out the platinum for their energy cells. And what is left? The gold. To them, the ratio might have been reversed. They kept the 1% of platinum and dumped the 99% of gold. This would explain why platinum is so much rarer in the Earth's crust than even our models of planetary formation suggest it should be. We assume it all sank to the core, just like the gold. But what if the surface was skimmed? What if the crust is platinum poor because it was harvested? There is a specific anomaly that supports this, the iridium anomaly. Iridium is one of the rarest metals on Earth. It is almost non-existent in the crust, except for a few very specific thin layers. The most famous is the KPG boundary, formerly KT boundary, a thin line of clay that circles the globe. This layer marks the moment 66 million years ago when the dinosaurs died. Science tells us this iridium came from a massive asteroid impact, the Chicxulub impactor. Asteroids are rich in iridium. Earth's crust is poor. So, when the asteroid vaporized, it dusted the world in this rare metal. But let's look at this through our industrial lens. If an advanced civilization was harvesting iridium from the solar system, transporting it in massive quantities, and if one of their transport ships, or a barge of refined concentrate, crashed, what would it look like? It would look exactly like an iridium bomb going off. We see a crater. We see a layer of global dust rich in iridium. We assume it was a rock. But a rock is a chaotic mix of elements. The KPG layer is surprisingly specific in its chemical signature. Is it possible that the event that killed the dinosaurs wasn't a random act of nature, but an industrial accident? A spill? And then there are the rare earth elements, REEs, neodymium, yttrium, lanthanum. Despite their name, they aren't actually that rare, but they are hard to find in concentrated deposits. They are essential for high-strength magnets, lasers, and electronics. Our modern world runs on them. If the others were building technology, they would have needed these. Are the scars we discussed in Part 8, the scooped-out lakes and the scraped plateaus, the remnants of rare earth strip mines? Consider the Oklo reactor in Gabon, Africa. This is one of the most famous geological oddities in the world. It is the only known location on Earth where a natural nuclear fission reactor formed spontaneously. About 1.7 billion years ago, Uranium deposits there were so concentrated that they began a chain reaction. Groundwater acted as a moderator, and the reactor ran for hundreds of thousands of years, generating heat and plutonium. Scientists explain this as a freak of nature, a perfect storm of geological conditions. And they are likely right. Nature is capable of strange things. But in a thought experiment about ancient industry, Oklo looks suspicious. It looks like a spent fuel dump, or worse, a meltdown. The uranium at Oklo is depleted in U-235, the exact isotope used for nuclear energy. It looks exactly like the uranium found in the spent fuel rods of modern power plants. If we didn't know about the natural reactor theory, any physicist looking at the isotopic ratios of the Oklo mine would say, someone ran a reactor here. Did they? Was Oklo a power plant for the mining operations in Africa? Did they burn the uranium to power the lasers that cut the gold from the quartz? And when the uranium was spent, did they just leave it there, allowing the groundwater to flood the chamber and cool it down? The missing element theory suggests that Earth is a depleted planet. We are like scavengers breaking into an abandoned grocery store, only to find that the shelves are mostly empty. The high-value goods, the iridium, the concentrated uranium, the osmium, are gone. What's left is the packaging, the rock, the spilled flour, the sand, and the heavy, useless decorative displays, the gold. We fight wars over the gold because it's the best thing left. But we have no idea what value really looked like to the ones who cleared the shelves. We prize the gold for its conductivity and its beauty, but we might be missing the point. The real treasure wasn't what was buried, it was what was taken away. And this leads to a chilling realization. If they took the fuel, they probably didn't stay. You don't strip a house of its copper wiring and its plumbing if you intend to live in it. You strip it when you are about to demolish it, or when you are moving out for good. The scarcity of platinum and the abundance of gold waste is not a sign of habitation. It is a sign of evacuation. If Earth was a mine, it was likely just one pit in a much larger operation. A civilization capable of reaching Earth would not ignore the rest of the solar system. In fact, the planets and asteroids surrounding us might hold even clearer evidence of this ancient industry, preserved in the vacuum of space where there is no wind or rain to erode the scars. Let's look at the asteroid belt. We often picture it as a field of floating rocks, the debris of a planet that failed to form. But what if it is the debris of a planet that was unformed? What if the asteroid belt is a tailings pile on a cosmic scale? There is an asteroid out there named 16 Psyche. NASA is sending a mission to it. It is unique because it appears to be made almost entirely of exposed nickel-iron metal. It is massive, over 200 kilometers wide. The scientific theory is that Psyche is the exposed core of a protoplanet that was smashed apart by collisions billions of years ago. But look at it as a miner would. It is a giant nugget of metal floating in free space. No crust to dig through. No gravity well to fight. It is the perfect resource. Or is it the perfect scrap heap? In metallurgy, when you refine ore, you separate the metal from the slag. You create ingots of pure metal. Is Psyche an ingot that was never collected? Or is it a clinker, a fused lump of metallic waste left over from the processing of a rocky planet? The value of the metals on Psyche is estimated in the quintillions of dollars. It contains enough iron, nickel, and precious metals to crash the world economy. If we can see this value, surely an advanced civilization could too. The fact that it is still there might mean it wasn't worth taking. Perhaps to them, iron and nickel were as common as dirt. They wanted something else, and Psyche is just the pile of rust they left behind. Then let's move to Mars. The red planet is a mystery. It is covered in iron oxide, which gives it its color. But there is a deeper mystery in its atmosphere. Mars has an unusually high concentration of xenon-129. Xenon-129 is a noble gas isotope. In nature, it is produced by the decay of iodine-129. But on Earth, the only time we see high spikes of xenon-129 is after a nuclear detonation. It is a signature of nuclear fission. Dr. John Brandenburg, a plasma physicist, famously and controversially proposed that this xenon-129 anomaly on Mars is evidence of a massive thermonuclear explosion in the distant past. He suggests a war. But in our bedtime documentary narrative, we don't need a war. We just need industry. Peaceful nuclear explosions have been proposed by humans for mining. In the 1960s, the Project Plowshare in the U.S. considered using nukes to dig canals and mines. If the others used high-yield nuclear devices to strip mine the surface of Mars, blowing away the overburden to get to the mineral-rich crust, it would explain the xenon signature. It would also explain why Mars is a wasteland. Did they strip its atmosphere? Did they use the water for their industrial processes, leaving behind a dry, rusted husk? The canals of Mars that early astronomers thought they saw were optical illusions, but the Valles Marineris, the massive canyon that dwarfs the Grand Canyon, looks like a tectonic tear, or a scoop, and finally, the Moon, our silent companion. The Moon is rich in titanium. The dark Maria seas of the Moon are basalt plains rich in titanium and iron. Titanium is a key material for aerospace, light, strong, heat-resistant. There are theories that the Moon is hollow, or that it rings like a bell when struck. While seismology suggests it has a small core, the density of the Moon is surprisingly low. Could the Moon have been a processing station? A slag planet, formed from the coalesced debris of Earth's mining operations? The giant impact hypothesis says a Mars-sized body, Theia, hit Earth, and the debris formed the Moon. This fits the physics, but it also fits the industrial narrative. A massive collision, controlled or accidental, to break the Earth open, releasing the heavy metals from the core, creating a ring of debris that could be easily harvested. The Moon is what formed from the leftovers. The craters on the Moon are generally circular, caused by impacts. But some are hexagonal. Some have flat bottoms. Some are lined up in chains. We call them catenae. Are we looking at the results of mass drivers? Are we looking at the bombardment of a surface to soften it up for extraction? The celestial junkyard hypothesis paints a picture of a solar system that has been rummaged through. The Earth, Mars, the Belt, the Moon, they all show signs of having been broken, melted, and irradiated. We look for life on these worlds and find only dust. Maybe that's because the life that was there was evicted, or because these worlds were never meant to be homes. They were meant to be mines. And when the mine is played out, you turn off the lights and leave. The silence of the solar system is the silence of a factory floor at night. The machines are gone. The workers have clocked out. And we are the mice scurrying around the dropped nuts and bolts, wondering where the giants went. And so we arrive at the inevitable question. If they were here, mining the gold, shielding the reactors, harvesting the platinum, and stripping the asteroids, where are they now? Why did they leave? The universe is silent. We listen with our radio telescopes, straining to hear a whisper from the stars, a signal, a song. But we hear only the static of cosmic background radiation. This is the Fermi paradox. If the universe is old and filled with planets, where is everybody? Our thought experiment offers a chilling answer. They were here, and they moved on. Consider the life cycle of a mine. You arrive. You build infrastructure. You extract the resource. The town booms. But eventually, the vein runs dry. The cost of extraction exceeds the value of the material. The company packs up, the town is abandoned, the wind blows through the empty windows. Is Earth a ghost town? The great departure might simply be an economic decision on a galactic scale. The others harvested the easy-to-reach metals. They took the platinum, the iridium, the rare isotopes. They filled their holds with the monoatomic gold. And then, Earth offered diminishing returns. It wasn't worth the energy to keep digging, so they lifted their ships. They dismantled their primary machinery, or took it with them, leaving only the heavy, useless infrastructure, the stone foundations, the leveled mountains, the injected waste veins. They engaged their drives and moved to the next solar system, the next fresh resource. This idea aligns with the Kardashev scale. A Type 1 civilization uses the energy of a planet. A Type 2 uses the energy of a star. A Type 3 uses the energy of a galaxy. A civilization transitioning from Type 1 to Type 2 doesn't stay on the rock. Planets are gravity traps. They are inefficient. You don't live in the mine, you live in the city. And for a Type 2 civilization, the city is likely a swarm of habitats orbiting the star, or a nomadic fleet moving through the void. Earth was just a resource stop, a gas station. And you don't stay at the gas station once your tank is full. There is another possibility, one that touches on the great filter. Maybe they didn't leave by choice. Maybe they collapsed. The waste we find, the gold, might be the tombstone of their civilization. Perhaps they polluted their environment with exotic isotopes or monoatomic instabilities that caused a collapse. The silence of the universe might be because high-tech civilizations inevitably poison themselves with their own byproducts. Did the gold bacteria get out of control? Did the atmospheric tinkering, the Sumerian sky repair myth, fail? Did the shielding crack? If so, the departure wasn't an exodus. It was an extinction. And we are the moss growing on the ruins. We are the second attempt of the biosphere to create intelligence, rising from the compost heap of the first. But let's look at the optimistic view. The ascension. Maybe gold isn't waste, and it isn't fuel. Maybe it is a bridge Some theoretical physics models suggest that heavy elements with specific spin states could interact with other dimensions. If the others were trying to access a higher plane of existence, a bulk universe, a hyperspace, they might have needed massive amounts of gold to build the resonance chambers or the gates. Once they succeeded, they stepped through. They left this 3D reality behind. They left their physical tools, their 3D matter, because they no longer needed it. They ascended. The gold veins are the footprints on the shore where they stood before they swam out into the ocean of the infinite. They didn't go to another star. They went elsewhere. This would explain the silence. They aren't broadcasting on radio waves because they aren't in this room anymore. In this scenario, our obsession with gold is a subconscious longing for that same ascension. We hold the key in our hands, but we don't know how to turn it. We use it to buy bread and land when it was meant to buy passage to the stars. The great departure leaves us with a profound sense of loneliness, but also a sense of potential. We are walking in the footsteps of giants. The resources they left, the gold, the uranium, the modified biology, are the starter kit for our own journey. They left the lights on, the sun. They left the pantry stocked, the biosphere. And they left a few tools lying around, the metals. Whether they intended to or not, they gave us an inheritance. The question is, will we use it to build our own ships and follow them? Or will we just sit here worshiping the waste until the sun goes down? The earth remembers the weight of their ships. The crust remembers the heat of their injectors. And the wind remembers the silence that fell when the last engine cut off and the sky became empty again. We are the children of that silence. And now it is our turn to speak. If this is true, if gold is waste, where does that leave us? In nature, there is no such thing as waste. The fallen leaf becomes the soil. The dead whale becomes the feast for the abyssal ecosystem. The ruin of one generation is the foundation for the next. This is the law of the universe. Matter is recycled. Purpose is reimagined. If an advanced civilization left billions of tons of gold, uranium, and rare earth metals in the crust of our planet, intentionally or not, they gave us a gift. They gave us the materials we needed to bootstrap our own technological adolescence. Think about the trajectory of human history. For thousands of years, we treated gold purely as an aesthetic object. We worshipped its color. We used it to make statues of gods and masks for kings. This was the childhood of our species. We were like toddlers playing with the wrapping paper, unaware of the tool inside the box. But as we matured, our relationship with the waste changed. We discovered electricity. We discovered that gold was the perfect conductor. We started pulling it out of the vaults and putting it into the machines. We put it in telegraph wires, then in vacuum tubes, then in microchips. Today, deep inside the silicon valleys of our processors, amidst the microscopic architecture of our digital age, gold filaments carry the pulses of our collective knowledge. We are finally using the metal for what it is good for. We are using it to think. We are using it to connect. And as we look to the stars, we are using it to shield. We are wrapping our most fragile explorers, our satellites, our telescopes, our astronauts, in the very skin that the others might have used to protect themselves. In this light, the waste hypothesis looks less like abandonment and more like a starter kit. Imagine a parent leaving a toolbox for a child. The child might play with the hammer as a toy for a while, but eventually they learn to build. Perhaps the gold, the platinum, and the uranium were left here because they are the necessary ingredients for a civilization to become spacefaring. You cannot build a starship out of wood and stone. You need heavy metals. You need radiation shielding. You need dense fuel. By concentrating these waste products in the Earth's crust, the previous inhabitants ensured that whoever came next would have a chance to leave too. There is a beautiful Japanese art form called kintsugi. When a ceramic bowl breaks, the artist repairs the cracks with lacquer mixed with powdered gold. The idea is that the break is not something to hide. The break is part of the history of the object. The gold highlights the scar, making the repaired bowl more beautiful and valuable than the original. Earth is a kintsugi planet. It has been broken by impacts, by tectonics, perhaps by ancient industrial extraction. The veins of gold running through the rock are the repairs. They are the golden seams holding the shattered crust together. And we, humanity, are the ones now holding the bowl. We are learning that our role is not just to consume the gold, but to understand it, to use it to repair our own broken systems, to use it to build a future that is resilient. The record is made of copper, but it is plated in gold. We sent gold back to the void. We took the material that came from the collision of neutron stars, the material that sank to the core and was dredged up by volcanoes or aliens, the material we fought over and died for, and we used it to write a letter to the universe. We used it because it is immortal. We used it because we know that 1 billion years from now, when the pyramids are dust and the continents have merged back into a single landmass, that gold record will still be shining in the dark between the stars, preserving the memory that we were here. If the others encounter Voyager, will they recognize the material? Will they smile to see that the rats in the walls finally figured out how to use the leftovers? Will they see it as a return of their property, stamped with the crude drawings of a primitive species? Or will they see it as we see the kintsugi bowl, as proof that something beautiful can grow out of the ruins? The inheritance is not just the metal, it is the challenge. The gold is a test. As long as we treat it as a symbol of greed, as long as we lock it in dark vaults to back up our currencies, we fail the test. We remain stuck on the surface, fighting over scraps. But when we start using it to build eyes that can see the beginning of time, like the James Webb Telescope, or to build voices that can speak to eternity, like Voyager, we pass the test. We graduate. We transform the waste of the past into the tools of the future. This brings us back to the silence of the earth. The mines are empty. The giants are gone. But the tools are still here. The scars on the landscape are not just wounds, they are foundations. The ghosts in the myths are not just hauntings, they are teachers. We are the inheritors of a mystery. And the more we dig, the more we realize that the true treasure isn't the gold itself. It's the curiosity that drives us to ask where it came from. It's the imagination that allows us to picture a history deeper and stranger than the one in our textbooks. If gold is waste, then we are the alchemists who have found the philosopher's stone. Not by turning lead into gold, but by turning the waste of the earth into the dream of the stars. We have taken the dross and made it into a mirror that reflects the universe. And perhaps, just perhaps, that was the plan all along. Maybe the great departure wasn't an abandonment. Maybe it was a planting. And we are the harvest, ripening slowly in the golden light of our sun, waiting for the day when we are ready to be picked. Or better yet, ready to fly on our own. We have traveled far tonight, you and I. We started with a simple question about a yellow metal, and we ended up drifting through the ruins of a galactic industry, wondering if our planet is a cradle, a mine, or a tomb. It is a lot to carry. The idea that we might be living on a used world, a planet recycled and reshaped by hands we never saw, is disorienting. It shakes the foundation of our certainty. It makes us feel small, temporary, perhaps even a little accidental. But let that feeling wash over you not as a fear, but as a comfort. There is a deep peace in knowing that we are part of a story much larger than ourselves. A story that didn't begin with us and won't end with us. If the Earth is a palimpsest, a manuscript written over again and again, then we are simply the current sentence being written on the page. The gold in the ground is the ink left over from the previous chapter. It is beautiful ink, immortal ink, and we are using it to write something new. Think of the gold ring on a finger, or the gold contact in the phone you might be holding. Feel the weight of it. That weight is the pull of gravity from a neutron-star collision billions of years ago. It is the memory of a journey through the cold vacuum of space. It is the legacy of the Earth's fire, and perhaps the shadow of an ancient machine. It is all of those things at once, waste and treasure, poison and cure, shadow and light. As you drift toward sleep, imagine the veins of gold deep beneath you, running through the crust like the nerves of a sleeping giant. They are quiet now. The current that once might have flowed through them has stopped. The machines they powered are gone. But the network remains, holding the planet together, waiting. And above you, the stars are watching. The same stars that watched the others arrive and watched them leave. They are patient. They have seen civilizations rise and fall like the tides. They know that everything is a cycle. The waste of one becomes the wealth of another. The silence of one becomes the song of the next. We are here now. It is our turn to hold the gold. It is our turn to look at the sky and wonder. It is our turn to build, to dream, and to leave behind traces for the future to find. Maybe, millions of years from now, another species will rise on this planet. They will dig into the ruins of our cities. They will find our plastic, our concrete, and our gold. They will wonder who we were. They will wonder if we were giants, or gods, or simply miners who lost their way. And maybe they will tell stories about us. Stories of a people who turned the Earth's blood into wires, who tried to touch the stars with mirrors of gold. They will look at our waste and call it treasure. They will look at our silence and call it mystery. Until then, we live in the mystery. We live in the beautiful, glittering, recycled world, doing the best we can with the inheritance we have been given. I hope this journey has given your mind a place to rest, a landscape of wonder to explore as the physical world fades away. The questions we ask tonight don't need answers right now. They just need to be asked. Because in the asking, we expand the boundaries of our world. We make the room a little bigger, the night a little deeper, and the dream a little richer. Thank you for spending this time with me. Thank you for letting me guide you through the mysteries beneath the earth. If you found some calm in these strange ideas, or if you simply enjoy wondering about what lies hidden in the dark, please consider liking this video and subscribing to the channel. It helps us keep the lantern lit for the next traveler who wanders in from the cold. Sleep well. Dream of stars. And remember, even the dust is made of light. Good night.